In this lecture, we will solve the problem 7.1 of Griffith 4th edition Introduction to Electrodynamics. The problem is problem 7.1 consists of three parts. We will see one by one that two concentric metal spherical cells of radius A and B respectively are separated by weakly conducting material of conductivity sigma as shown in figure. There are two concentric cylinder, one for which one is with radius A, the other one is with radius B, and this between A and B there is a conducting material. The conductivity is sigma. So now the part A is if they are maintained at a potential difference of V, what current flows from one to other. So now our task is we have to find the current flow from the sphere of radius A to sphere of radius B. So first, in order to find the current, we need a potential difference. Difference. Of course, we know the conductivity here. So the potential difference between the point A and point B, VA minus VB is equal to, by definition, minus integral over P to A E dot Ti. Ti is with small element, small length element. So by we know by definition E is equal to Q divided by 4 pi epsilon naught R squared R cat. Now you replace this E by this one. Now you take the constant outside, that is minus is here constant is q divided by 4 pi epsilon naught integral between p to a 1 over r squared tr. If you integrate 1 over r squared, you will get minus 1 over r. So naturally this minus and minus 1 over r will become plus. So this will be q divided by 4 by epsilon naught 1 over r. The upper limit is a and lower limit is b. If you apply upper and lower limit, va minus vb is equal to q divided by 4 by epsilon naught upper limit 1 over a, lower limit minus 1 over p. Now we have to find the current. So now we have to calculate the current. We have find the potential difference between point A and B, which is equal to Q divided by 4 pi epsilon naught multiplied by 1 over A minus 1 over B. Now what is Q? You bring 4 pi epsilon naught to the other side. So this will become 4 pi epsilon naught in the numerator multiplied by VA minus VP. Then this will come into denominator. That is 1, 1 over A minus 1 over B. So I have brought this to the left hand side, this side. So I have brought this side. So this will become to the new denominator like this. So now you bring this epsilon naught to the left hand side. Now epsilon naught, then q by epsilon naught is equal to 4 pi Va minus Vp divided by 1 over A minus 1 over P. Now we have to find the current. Current I is equal to integral J dot dA. J is current density. If you multiply this by area, then you will get you have to integrate over an area, small area dA, then you will get total area. That is different. So J by definition we know J is equal to sigma E. This is equal to sigma E, where sigma is constant. So I am taking sigma outside. So E dot dA. So integral over E dot dA, from Gauss theorem, this is nothing but, sorry, this is nothing but the total charge Q. So from the Gauss theorem. So naturally, I is equal to sigma. By Gauss theorem, this is equal to Q over epsilon naught. That is from Gauss theorem. This is from uh, Gauss theorem. So this is from Gauss theorem. So now you replace this integral by q by epsilon naught. So this will become q multiplied sigma multiplied by q by epsilon naught. Here we have seen the value for q by epsilon naught. So you replace this for this q by epsilon naught. Then this will become sigma 4 pi Va minus Vp divided by 1 over A minus 1 over P. This is the current. So this is the current flows from A to P. Now, what is the resistance between the cells? So resistance is nothing but voltage divided by current. So here you take this expression, you bring current here to the right hand side and all other term to the left hand side. This will become into the numerator, that is 1 over 1 over A minus 1 over P. This will become into the numerator. I am taking this I here. Then in the denominator you have 4 pi sigma. Here when you bring this you will get 1 over 4 pi sigma, which is equal to multiplied by 1 over A minus 1 over P. So this PA minus PP divided by I is nothing but resistance, which is equal to 1 over 4 pi sigma multiplied by 1 over A minus 1 over P. Now we will see the part 3. Part C is, notice that if P is very much greater than A, the outer radius P is irrelevant. How do you account for that? Exploit this observation to determine current flowing between two metal spheres, each of radius A immersed deep in C and held quite far apart, as shown in figure 7.4p. If the potential difference between them is V, this arrangement can be used to measure the conductivity of seawater. We know, just now we have seen R is equal to 1 over 4 pi, 4 pi sigma multiplied by 1 over A minus 1 over P. Now, P is very much greater than A. So naturally, since P is very much greater, this will be insignificant. This can be treated as, we can ignore this can be zero. So the resistance is 1 over 4 pi sigma A, that is independent of P. So it is P is irrelevant. Now for a C in our problem, there are two sphere like that, for which the uh, inner radius A is very much A is very much greater than very much less than A. So P is very much greater than A. So P you can ignore. So the total resistance is centered at the center of the inner sphere. So that is the meaning of this. You have two spheres such like that. So the total resistance is this and plus this is 2 times multiplied by, 2 times divided by this one. Uh, so 4 pi sigma A, that is 2R. 2R is equal to 2 times 2 divided by 4 pi sigma A. Then R is equal to, this 2 will get cancelled. R is equal to 1 over 2 pi sigma A. Then what is current? I is equal to V by R. So 1 over R is equal to this. This is 1 over R. So this factor 1 over R, and we are multiplying it by V. So we can measure the current by using the formula 2 pi sigma A V. Thank you very much for watching my video continuously and supporting me. Thank you very much.